This is part 3 of the chapter 14 homework, starting with number 71. We have a refrigerator with a coefficient of performance of 3.8. The energy consumed is the work. That's the work done by the motor. Q sub L is the heat removed from the interior. So the coefficient of performance is Q sub L over W. And so if we want to know what Q sub L is, the heat removed from interior, algebraically we can see that's coefficient of performance times work, which is 3.8 times 600 joules. We keep in mind that this is every second that passes by. So we get 2280 joules per second, which is 2280 watts. Number 95. 4 liters of water brought from 9 degrees Celsius to 1 degree Celsius. What is the heat extracted? This goes back to a previous chapter in thermodynamics, chapter 13, where we did Q equals mc times delta T. You need to know the mass of 4 liters of water. It's good just to know offhand that a liter of water, think of the water bottle that I often have in class, that is 1 kilogram. So a liter of water is 1 kilogram. However, if you don't know that, you can do what I have in the box right here. Mass equals density times volume. Density is 1,000 kilograms per meter cubed times 4 liters. You have to get liters in meters cubed, so the conversion is 1 meter cubed equals 1,000 liters. And there we get that the mass is 4 kilograms. Now back to the heat equation. Q equals 4 kilograms times C, 4186 joules per kilogram Celsius degrees, times the change in temperature. This is an error right here. I wrote 9 minus 1. Remember, as I often say in class, final minus initial. So this should have been 1. Let's just change that right here. And that should be 9. How about that? Final minus initial, 1 degree Celsius minus 9 degrees Celsius. So then we get Q equals negative 133,952 joules. Now that mistake I made in the previous line, it's not going to matter because we're really looking for the absolute value. When we apply in chapter 14 QL and QH, were what I said at the beginning of that lesson on heat engines is that we use absolute values for these. So the mistake that I made up here wouldn't have made a difference. Right here, we switch to the absolute value anyway, 133,952 joules. So what is the motor's work? We need to remember that power equals work divided by time. Therefore, work equals power times time. We have 130 watts times 240 seconds. So the work is 31,200 joules. Now we can figure out what the coefficient of performance of the refrigerator is. QL over W, plug in those numbers, and you get a coefficient of performance of 4.29. Remember, the difference between coefficient of performance and efficiency, and why we don't call coefficient of performance efficiency, is that it's not limited to 100%. It can be greater than 1, as you see in this case. Now, the ideal or the maximum coefficient of performance, here are the operating temperatures. If T sub H, so you can imagine this is the air outside of the vent of the refrigerator, is 25 degrees Celsius. It said earlier in the statement of the problem that the inside temperature is 1 degree Celsius. Coefficient of performance in general for a refrigerator is QL over QH minus QL. And that actually comes from up here, where work by conservation of energy is QH minus QL. So the ideal or the maximum coefficient of performance, switch those Q's to T's, and you get TL over TH minus TL. Plug in the temperatures. Look what I've done. kind of playing fast and loose with these units here, but it works. The numerator is an absolute temperature, so it must be in Kelvin, so 274 Kelvin. The denominator is actually a difference in temperatures, so you can keep it in Celsius, 25 minus 1, and it gives a difference of 24 Celsius degrees, or 24 Kelvin. You could, if you wanted to, just to be safe, have converted these temperatures in the denominator to Kelvin. That would have been, 298 Kelvin minus 274 Kelvin. But when you subtract them, you still get a difference of 24 Kelvin. So just remember, whenever you're doing an absolute temperature, it has to be Kelvin. But when you're doing differences of temperature, it can be Kelvin or Celsius degrees. Either way, when you do that math, it comes out to a coefficient of performance of 11.4.